In Chapter 6, we're going to look at the normal distribution curve. We've already looked at that back in Chapter 3, and we looked at three values there. The important thing to remember here with our normal distribution curve as we go further is that our mean, or 0, cuts that curve in half. 50% of the values on this side and 50% of the values on this side, right and left. When I put 0 here, I mentioned the word mean. Our standard normal distribution curve translates the mean to what we call a standard score or a z-score. So the mean is 0 standard deviations away from itself. So it starts here, and then everything that goes this way means that score is below the mean. We're measuring how many standard deviations is below the mean. Anything that goes this way is measuring how many standard deviations we are above the mean. The other thing, bottom line, is we have a table that we use, and that table from this particular textbook measures the area, which eventually also becomes a probability, but that area under the curve from the z-score that we look up to the left of the curve. When I say z-scores are typically written in 2 decimal places, so I might have 1.65. Notice the 2 decimal places here, the nearest hundredth, and that value is found then underneath the normal distribution curve, or from this table. So taking a look at the table here, here's our table, at least one side of it. Here's the positive version. So I'll just jump down here. 1.6 is right down here. And then we go across the top where we have 0.05. And if we come straight down and straight across from that, you can see that our area under the curve is 0.9505. And again, we'll come back to that here very shortly. But here's our first example using that table. It says find the area between a z-score of 0 and 2.34. So on our curve here, I just mentioned 0 cuts that curve in half. 2.34 is here, and we're trying to find the area between those two scores. Okay, so I'm going to go to my table here, look up 2.34. Oops, 2.34. So our fourth column is going to be the fifth one, 2, 3, 4, fifth one over. So 2.34 is 0.9904. There's our area under the curve. So I take that back to here. 0.9904 is the area of 2.34. What's the area from 2.34 all the way down to the left? Obviously, we're cutting off right here. So I want to get rid of this part down here. I mentioned earlier that 0 cuts the curve in half, so we have to subtract out 0.5. So the actual area between 0 and 2.34 is 0.4904. Okay, so again, bottom line is that table we're working with measures the area from the z-score to the left. Second example, find the area between z equals 0 and z equals 1.8. Sketching our curve here again, 0 cuts that curve in half, 1.8 here. We want the area between those two. So once again, we'll go to our table, look up 1.80, that's 0.9641. And 0.9641, again, is the area from our z-score, 1.8, all the way down. We don't want the area all the way down. We want to take out this part right here. So we'll subtract 0.5. and we'll get 0.4641. Continuing to learn how to use the table, it says find the area between 0 and negative 1.75. So as I sketch here, my curve, I put 0 in the middle. A negative z-score is on this side. We want the area between those two. So we'll go to our table. I have to scroll up a page here to get negative 1.75. Negative 1.75 would be right here, 0.0401. Now again, 0.0401, that is now a measure from here down to here. Now obviously not the shaded part, so in this case we subtract that number from 0.5 because again 0 cuts our curve in half, so 50% is on this side. If we take this 0.0401 out of the 0.5, we're left with what's left between 0 and 1.75, or 0.9599. Okay, so again, the z-score that we looked up measures the area to the left. In this case, we want the area between 0 and negative 1.75, so we had to subtract from 0.5. Continuing on to get used to those scenarios, We have find the area to the right of z point equals 1.11. So I'll sketch that into our curve yet again. 0 here, 1.11. To the right of that would be out here. So we go to our table, look up 1.11, and 1.11 is right here, 0.8665. So taking that back, I have 0.8665. Once again, that 0.8665 is a measure of 1.11 on down. We want the area on the other side. Well, our curve represents 100% of itself, so we subtract that from 1 to get the area out to the other side, and we get 0.1335 as our area here. Let's go to the next one, left of negative 1.93. I'm going to continue to sketch these on our curve. Put 0 here in the middle, negative 1.93 on this side. It says to the left of that, so I'm going to shade to this side, go to my table and look up negative 1.93. Negative 1.93 is 0.0268. Negative 1.93 here. So 0.0268. Now again, our table measures the area from here to the left, which happens to be what we shade. So this time the 0.0268 is our actual area under the curve to the left of negative 1.93. Continuing on, the area between z equals 2 and 2.47. So sketching that into my curve, I'll put 0 in here as my reminder, 2.00 here, and 2.47 here. We want the area between those two. I'm going to go to my table, look up 2.47 first. 2.47, 2.40, 1, 2, 3, 4, 5, 6, 7 is 0.9932. I'll bring that back to my curve, 0.9932. Now keep in mind that 0.9932 is the area from here all the way down. I go back to my table and look up 2.00 or 2.0. 2.00 would be right here, 0.9772. So I'm going to bring that back to my chart, my note, 0.9772. Let me just verify that I didn't, yeah, 0.9772 was right. And because that's the area from here on down, if I subtract those two, that will give me the area between them, and that area is 0.0160. Okay, so we will subtract out the areas between two different z-scores. The area between z equals negative 2.48 and negative 0.83. 0 cuts the curve in half. Negative 0.83 here. Negative 2.48 here. The area between those two. As we just discovered in our previous example, if we look up both of our scores, we'll wind up subtracting those areas. So I would suggest looking up the one farthest to the right first. So I'll look up negative 0.83, which means I need to go back up a table. Negative 0.80123 is 0.2033. And that again is the area from here all the way down. I'm going to go back and look up the area for 2.48. So negative 2.48 would be here, 0.0066. 0.0066, that's the area from here all the way down. We want the area between those two, so we'll subtract, and that gets us 0.1967. One more time with that same idea, find the area between 1.68 and negative 1.37. So I'll put 0 down the middle, 1.68 on this side, negative 1.37 on this side. We want the area between those two. So our process is going to be the exact same thing. We'll look up 1.68 first. 1.68 would be right here, 0.9535. Then we'll go back and look up negative 1.37, which means I need to scroll back up to the other page. Negative 1.37 will be 0.0853. And as we've discovered with our last several problems. We're going to subtract those two, and that gets us 0.8682 as the area between those two scores. Bottom line here is we understand the curve or our table that we're looking at. That table measures the area from whatever z-score we look up all the way to the left. Doesn't stop anywhere, it goes all the way to the left. Let's go through a few more here. Changing, instead of having the phrasing here, it's now written as an inequality. As I mentioned, our probabilities and our areas are the same thing. Okay, so we're just translating this to a probability. If I were to sketch this, I have my curve here. With 0 down the middle. 1.99 is on this side. So our z-score says it's less than that, so I'm going to shade all the way down the left. This is everything to the left of 1.99 is less than that, which means when I go to look up 1.99 on my table, 1.99, clear out here, 0.9767, that is actually the area under the curve to the left, 0.9767, so that is our answer. Let me just verify that was right. Yep. Okay, so that area again is all the way over here to the left from 1.99 all the way down. Z is greater than negative 1.16, so I'm going to sketch this again. 0 here, negative 1.16 here. It says greater than, which means I shade all the way to the right, so I'm going to shade out in here. So now when I go to look up negative 1.16, negative 1.002, 1, 2, 3, 4, 5, 6. I get 1.230. 0.1230 is the area from my z-score to the left. I want the area to the right, so I have to, in this case, subtract it from 1. So 1.0 minus 0.1230 gets me a value of 0.8770. Okay, so inequality is the same thing as saying are between than or less than or to the right of, to the left of, obviously just written in a different format. Let's go one more time between 0 and 1.45. So our z-score is greater than 0, so going this way, less than 1.45, so 1.45 here going this way, so we're finding the area between those two. So again, another way of saying between 0 and 1.45, like we saw with our previous ones. We'll go to our table and look up 1.45. And 1.45 is right here, 0.9265. And again, that 0.9265 measures the area from here all the way down. We don't want anything below this, so we'll subtract out that 0.5 and get 0.4265. One more example here. Find two z-values that in the middle 90% is bounded by them. So I'm going to start with our curve here. We know our curve is cut in half by 0. So the middle 95% would put 45% on this side and would put 45% on this side. In other words, we're looking for these z-scores right here that would make that happen. So here is our middle 90%. 45% on each side, or 90%. Now as I write that, I like to write that as a decimal, 0.4500 or 0.9000, just to remind us that's an area under the curve. So essentially what we're doing here is working backwards, looking for this z-score. So knowing that our table measures the area from a z-score to the left, if 90% is in between, that means there's 10% outside of that in here and in here, or 5% on this side, which is 0.0500 as a decimal. So I'm going to go to my table and look up 0.0500 inside the table and find the value that comes closest. So I scroll down here, here's our two values. These two are the same distance away, 0.0505 and 0.0495. They're both 5/10,000ths away from 0.0500. So ideally, in an ideal situation, they're pretty much interchangeable, but in an ideal situation, we're going to use the larger absolute value. So we have a choice of negative 1.64 or negative 1.65. The larger absolute value is negative 1.65, so that's the z-score I'm looking for here is negative 1.65. Now the good news is our curve is symmetric, so my z-score on this side is the same version or a positive 1.65. Or we could think of it this way, if from here to here is 90%, we have another 5% here, so we have a total of 0.9500 or 95% from here on down. We could go to our table and find that value as well. 0.9500 is closest to these two right here. Again, they're both the same distance away, so I scroll back and I get 1.65. Okay, so we have our middle 90% bounded by plus or minus 1.65. And there's our introduction to the normal or standard normal distribution curve.